Okay, this is the Chapter 7 test review. And as we go through this, I'm just going to kind of go through it from the beginning. Hope you have your test review out in front of you. But the first one is a graph, and so I'm going to go right to my y equals on my calculator. It starts with e, which is the second function of the ln key down here. E raised to the negative 2x. I'm going to get out of the exponent minus 2. And I'm going to go ahead and graph that. And we can see this is a graph that kind of flattens out as it goes to the right. It's going to be important for answering question number 3 here in a second. Oops, let me grab a pen. Kind of a coordinate plane here. Now, one of the things to keep in mind, is y equals e to the negative 2x minus 2. That minus 2 right there tells me that down here at negative 2, I have a horizontal asymptote. You're going to want to draw that in to give yourself a boundary, but also communicating ideas to me. It's going to be very helpful. So the next thing I need is some data. I need at least 2 data points from my table. I see 0 gives me negative 1, and negative 1 gives me 5.4. So I'm going to go ahead and plot that. 0, negative 1, and negative 1's at 1, 2, 3, 4, 5. 5.4 be around there. And that should be enough for me to kind of, I like to follow the asymptote, and then I'll turn, and it kind of goes up really steeply. Obviously, it still trends to the left, and that allows me to come up with the domain and range. The domain for all exponential functions is all real numbers, and the range is bound by the asymptote. So in this case, y is above or greater than the boundary line at negative 2. While I'm on this question number 1, question number 3 asks if this is growth or decay. If you think about what's happening as it goes to the right, as it's dying off, it's flattening out, that makes it a decay. So that's answer to question number 3. Okay. Number 1 is this graph with the domain and range, and 3 is the word decay. So now number 2 had y equals 5/4 to the x plus 3 plus 4. Again, we know that 1, 2, 3, 4, there's going to be a dotted line. Whether we're above that line or below that line depends on the graph and the equation. I'm going to come in here and I'm going to graph parentheses 5 divided by 4 raised to the x plus 3 over plus 4. As I graph that, there's my flat spot. And then it is creeping up. It's not growing real fast, which is kind of nice because I can get this graph drawn a little easier. But I see negative 3 gives me 5. And yeah, I mean, you're kind of looking at whatever. Negative 1 is 5.5. Maybe I go to negative, or go to positive. Yeah, these are not going to be perfect numbers. So negative 3, 5, negative 1, 5.5. So negative 3 should be at 5, right around there. Negative 1 was at 5.5, which should be about there. Where this is growing real slowly, sometimes it can be frustrating to actually draw, but just try to do the best you can. It's nice and flat, and then it's going to start curving up, trending upward. You really want to make sure it has that curve, that it's going to eventually get steep and get up there. It just grows real slowly for a long time. And then we have our domain, which we know is all real numbers, and then our range, which is y. In this case, again, we're above, which is greater than the boundary line at 4. Number 4, we're going to ask whether this is growth or decay. As you go to the right, it is separating. Okay, it's not just about going up; it's separating from the asymptote. That makes it growth. Will there be one of each on the test? Maybe, maybe not. It'd be a pretty good joke if Mr. Welch put both growth or both decay and really tried to see if you knew what you were doing as part of that. So kind of keep that in mind. You just need to look at the graphs and understand the difference between them. All right, let's keep going. Question number 5 and 6 are about the transfer, which is based around b to the x equals y is interchangeable with the logarithm base b of y equals x. So this interchange between the two sides is at the heart of 5 and 6. Number 5 has 5 equals 7 to the x, and we want to write it as a logarithm. Okay? And so we're thinking about are 3 pieces. I could tell that b in this problem is 7, so b should be 7 as a subscript. The exponent, x, in this problem is still x, so I know that this logarithm will equal x. And the number I haven't used, the thing that the exponential was equal to was 5, so 5 goes in the parentheses. And there's my number 5. Number 6 asks us to do the same thing in reverse. 6 equals log of 3x. Now this is a tricky one. Whoops. So undo that. All right. 3x. This is where this gets tricky, is that there's no base written. We need to have a number down here. Now it's not written, but it's implied that that's going to be a base 10. Okay, so you're going to need that number in order to work it. Now we're looking over here. Okay, we want to create a b to the x. Well, our b is in the base of the log, which is 10. So we're going to go 10 raised to the exponent comes from what the log is equal to, and since the log is equal to 6, 6 must be my exponent. And then it's equal to whatever was in the parentheses, and that's 3x. There's my exponential version of the logarithm. All right. Let's turn the page and look at what's next. Question number 7 and 8 are about expanding and condensing logarithms. So 7 has the log of 2y cubed over xz squared. Now each of these things, there are 1, 2, 3, 4 of them, need their own logarithm. So we're going to start log parentheses, log parentheses, log parentheses, log parentheses. I'm going to have one for each of them. As I put them in here, the 2, the y, the x, and the z, there's a couple things to be aware of. First, if it comes from the numerator, it's positive. So this log at the beginning would be positive, but I don't need to put a positive sign there because it's just a logarithm. It starts with a positive automatically. The next log, which would be my y, that should be a positive log. Then the x and z logs, because they come from the denominator, should be subtractions. The last thing we have to identify is that anything that has an exponent, that y had an exponent of 3, that y's exponent is going to go right in front of the logarithm. And the same thing with this 2 on the z, it's going to go right in front of that logarithm. It doesn't go in front of x's and z's, just the one that it's attached to. And that's a fully expanded logarithm. Log of 2 plus 3 log of y minus log of x minus 2 log of z. And number 8 asks us to do the same thing, but backwards. We have log of 3 plus 2 log of x minus 3 log of y. And as we compress this into a single logarithm, okay, first thing we look for is there subtraction? Because if there is subtraction, I'm going to have a fraction. I know right there I have some subtraction. Everything that's positive belongs in the top, so I've got a 3 on top. I've got to have an x on top. Everything that comes from a negative, like y, goes on bottom. The last thing is to reverse these exponent rules. Since 2 goes in front of the log of x, it must be the exponent of x. And since 3 is in front of the log of y, it must be the exponent of y. And that's it. So we see a lot of backward and forward on these. And that's kind of how this whole test is built. Number 9 just asks you to evaluate log base 8 of 64. Now if you know how a log works, you know the answer is 2, because 8 to the second power is 64. If you're not sure, we can go to our calculator, turn it on, go to the main page, and what we press is not log, although there is a way to do log of 64 divided by log of 8. I find a lot of people get that mixed up and they actually do them in reverse. We can see that gives us 2, but the other option on these newer calculators is to hit the math button. It's actually quicker to scroll up. Option A there says log base. And when you do that, it gives you the option to put the subscript 8 and then the 64, and we can evaluate that as 2. That's a pretty straightforward problem. Now 10, 11, and 12 all require a little bit more work. So if we look at number 10, we have 4 to the 3x minus 2 equals 16,483. And we want to solve for x. Now, this is an exponential. Traditionally, to solve an exponential, we want to go to log form. That's the same thing that we did on the previous page with 5 and 6. So this would be a log with a base of 4, right? There's our base. The logarithms always equal the exponent, so that exponent belongs on the other side, 3x minus 2, and the thing that we haven't used drops into the parentheses, 16,483. All right, so now we can evaluate this in the calculator using the same thing we just did. So this would be math, scroll up to log base, the subscript was 4, and we were doing 16,483. We get roughly 7.00. So we'll call 7.004. 7.004 equals 3x minus 2. To solve, we just add 2. 9.004 equals 3x. We divide by 3, and our calculator gives us the number. We add 2 and divide by 3. Gives us 3.001. We'll call that x equals 3.001. We're going to see the same thing happening again and again in terms of how do we answer 11 and 12. I know you guys can pause it and go back and rewrite what you need to. Number 11 has e to the 2x. There's a plus 3 equals 18. We need to recognize this is again exponential, so I want to write a logarithm. However, this plus 3 is not part of the base and it's not part of the exponent, so it needs to go to the other side. So I'm going to minus 3. You get e to the 2x equals 15. You can see the base, the exponent, and the solution are what it equals. This should allow me to go to the logarithm. Now, I can write log base e, or simply I can write ln, because ln is the log with a base e. It's implied. Now, if you write log base e, it's not going to be wrong. How you type it in the calculator is similar to how we wrote the last one in the calculator. This just saves us a little bit of time. We know logarithms always equal the exponent. Because the exponent was 2x, this will equal 2x, leaving me with a 15 to put in. Again, the log I can put in a calculator, and because it's an ln, I'm just going to push the ln of 15 to get 2.708. 2.708. Try not to round these too much, or else you just cut a bunch of stuff off. If I divide that by 2, I get 1.354. Why not? Number 12 is the one that's going to actually require us to go in reverse with this. So we look at number 12. We have 7 equals log base 3 of x plus 7. Okay, and a problem like this, because it's in log form, we actually want to transfer it into exponential form. And so we've talked about the base being 3. Now I need the exponent for this, but we know every logarithm equals the exponent. So this would be the exponent on the 3, and therefore it equals the x plus 7. This transformation that we've done 3 times now on this part and earlier in the test as well, it's critical that we understand how to make that transformation cleanly. 3 to the 7th is going to be a pretty big number. My guess is 2187 equals x plus 7. If I minus my 7, I'm going to get 2180 equal to my x. And we move on. All right, last page, last couple of problems. We get heavily into whoops, let me just clear it. We get really heavily into working with our interest and rate of growth formulas. And so on number 13, you're going to have a equals a naught times 1 plus or minus r to the t. This is as simple as we can make it. We're talking about things like original amount. So the a in our equation is 24,000 times 1. Now this is a car that's depreciation. That means it's decreasing in value, so I'll use a minus. The rate was 12%, so that's 0.12 to the t. Now, they tell us that we want to know the value of the car in 4 years. So I'm going to get rid of this t and put a 4 there. this is something I can just simply evaluate in the calculator. So I'm going to take my 24,000 parentheses 1 minus 0.12 close parentheses raised to the 4. And that gives me 14,392.69. 14,392.69. And that's the value of my car after 4 years of driving it. That was question number 13. 13 is going to be built around this formula here. Now 14 and then our bonus gives us a choice, okay? On 14, it could be A equals P times 1 plus R over N raised to the NT, or it could be A equals P e to the RT. Depends on the word continuous. If you see the word compounded continuously, you see that phrase, that tells you to use this equation. If it's weekly, monthly, daily, anything like that, it's over here. So in this problem, it says we're investing $3,000. It's paying 5.5% interest compounded weekly. That tells me I'm going to use this equation. So the A will equal the amount I put in, which is 3,000, times 1 plus the rate is 5.5. That's 0.055 over. If I do this weekly, okay, that means that there would be 52 weeks in a year, and this would be raised to the 52 times my t, which they tell me will be 2 years. So now again, we can just evaluate this in the calculator. I'm going to grab my calculator. We'll pull this one over this time so we can see a little better. 3,000 parentheses 1 plus 0.055 divided by 52 close parentheses raised to 52 times 2. I get 3348.64. 3348.64. So in 2 years, I made a little over $340, almost $350. And that's just how you're going to evaluate that. If it was continuous, obviously we have our E. That gives us that value for continuous compounded interest. Last question is our bonus. And this is really where the payoff comes. This is the real world application of a lot of this stuff. We want to know about time. Time and when does certain things happen. When is it safe to pull uranium, that's radioactive waste, out of the ground? How long does radioactive decay last? Other things like that. When is our business going to be worth enough money? And so it says we want to double $2,000. Wants to become 4,000. Okay, that's what doubling would do. And we have 4.5% interest compounded continuously. That word continuous means that we get to use A equals P e to the RT. And so as we go in here, we first off put 4,000 for our amount we want, 2,000 for what we started with. E raised to the 0.045 and an unknown time. And the question comes, how the heck do we solve for this? Well, this is the exact same thing that we did on question number 11 or question number 10, where we were solving for an exponent. To solve exponentials, we have to go to logarithmic form. However, this 2,000, it's not part of the exponent, it's not part of the base. It needs to be gone. So I'm going to divide by 2,000. And we get 2 equals e to the 0.045t. This we can write as a logarithm. Because it's base e, we write it as ln. We know that the base down here is e. We don't have to write it, but it's there. We know every logarithm equals the exponent, 0.045t, and the thing that we haven't used was the 2. This again, and I'm going to go upward, this goes into our calculator. Where'd you go? The ln of 2 is 0.6931. 0.6931 equals 0.045t, and that's just a division that I have to do to get my t solved. I'm going to take my number and divide it by 0.045 and get 15.4 years. And we're done. That's the whole test. Hopefully that's enough to get you what you need on your test review. And come in and ask questions.